All right, last time we discussed about metallurgy. Today we are going to discuss one particular metal. Okay, I want to know my name. My name is so that's my name. I hope you have known my name now. All right, let's look at chemistry of lead. Are we ready? First, listen carefully, please. First, we're going to consider how lead occurs in nature. What is the main occurrence of lead in nature? How does lead occur mainly in nature? Galena, right? And that galena is known as the ore, true or false? So, ore, you know that. Now, the next thing, having known that the main occurrence of lead in nature is galena, that is the important occurrence known as the lead ore. Lead ore is galena. Okay. The next thing is, how do I get that galena? Metallurgy of lead. The main ore of lead is what? Is it galena? That's nice. So after that, we talk about metallurgy. How do we get lead from the galena? It takes some stages, right? Now, galena, looking at galena, the main component of galena is what? PBS, right? That is lead 2 sulfide. That is the main component of galena. Is it a sulfide ore or not a sulfide ore? It's a sulfide ore, right? Now, what method is normally used to concentrate a sulfide ore? Of all the method I told you, which one is normally used to concentrate a sulfide ore? Froth what? So froth flotation. Why did you choose froth flotation? Because it's a sulfide ore, right? So galena is concentrated by what? Froth flotation. You should also know that the galena is normally accompanied by what? Galena is normally accompanied by zinc blende, by sphalerite. Do you remember that? Did I say that? Galena is normally accompanied by what? Sphalerite. What is sphalerite? That is a zinc blende, right? Of which the main component is zinc sulfide. So it normally, please, I want you to listen. Listen. A student is supposed to possess 3 important qualities whenever you are in the class. 1, think more, listen more, write less, and talk less. Talk less, write less, think more, listen more. Listen, let me tell you one secret to pass JAMB. JAMB and WAEC are not the same. The main secret to pass JAMB is understanding. Is what? Understanding of what you are learning. You don't cram anything to pass JAMB. You do not cram and even pass questions to pass JAMB. Because that question you think, suppose JAMB repeat that question, they can twist it, they can change it to another form. If you don't understand that thing, you will fail the question. So the best is to understand something. The questions you are going to encounter are multiple choice questions. The moment answers are given, you understand it and then choose the best choice, the best option, right? So you have to pay attention. That's why you have to listen more and think more. Do not write too much. Too much writing is not good. I'm going to take it slowly, so that most of whatever thing we're going to say will be in your what? Brain. Not writing. And after writing, you will not even pick much. So it is important. Now, so we will not be writing much thing. So when I want you to write, I will ask you to do what? Write. Is that right? Now, since you know, like we said, the main ore of lead is galena, right? Galena. And the main component of galena is what? Lead 2 sulfide. Who can tell me the color of lead 2 sulfide? Is it black? Lead 2 sulfide is what? Black. Lead 2 sulfide is what in color? Now, galena, what do you think should be the color? What do you think should be the color of galena? Black. Due to presence of what? Lead 2 sulfide. So, now, we now know that lead 2 sulfide is a sulfide ore. So, and sulfide ores are mainly concentrated by what? They are mainly purified by froth flotation. Froth flotation. Now, what do you mean? What do you do? What do you achieve by this method? To remove some gangue. Do you remember what gangue is? Yes. All these 18 impurities, right? Yes. Remove them. So after removing the gangue, you now have the ore. Then the next is to do what? If it's a sulfide ore, you roast. You do what? Roasting. When you roast a sulfide ore, you convert it to oxide. You convert it to what? So during roasting, you find out that lead 2 sulfide will interact with oxygen to form lead 2 oxide and sulfur 4 oxide. And what? Remember that the galena is mixed with what? This. So this will also undergo its own reaction too. Two of them are roasted at the same time. So can you tell me the product now? Based on this, can you tell me the product now? Zinc oxide plus what? Sulfur 4 oxide. Okay, let's balance the equation. Is it balanced? Can you attempt to balance? Balance it by yourself. Try it. 1 minute. The moment you balance this one, you have balanced this one. 1 minute, everybody balance this equation. Everybody should balance this equation. Chemical equation. One minute. Everybody should balance. Be fast about that. Who has finished? Who has finished? This is not yet an equation. It is just expression. It's a chemical expression. It cannot be equation until you have what? Balanced it. When you're talking about the equation, you're talking about the quality, right? So it's not yet an equation. It is only when you have balanced it that it becomes what? An equation. What it is now is an expression, is it right? When you balance it, it becomes an equation. So have you balanced it? Have you balanced the expression? Okay. So what did you do? What did you put here? You put 2 here. What made you? I want to know what came into your mind and made you to put 2 here. How did you do that? Oxygen. Okay, what? Oxygen and what? Sulfur oxide, right? Okay, let me help you with this. Look at these 2 things. Look at this. Before you balance an equation, before you balance an expression, please. It's not equation. Remember I said it's not equation unless you have done what? Balance it. When you want to balance a chemical expression, that is, you want to make it an equation, you have to check the subscripts of each of the formula. How many lead can you find here? How many sulfur? Total subscript is what? 2. 1 plus 1. That is what? 1 lead plus 1 sulfur is equals to what? 2, right? Let's come here. How many subscript here? 2. 2. So this is 2. This is what? 2. Let's come here. How many? 1 lead and 1 oxygen. Total subscript is what? Now come here. How many subscript? 1 sulfur and 2. That is what? 3. I will start my balancing with the one with highest subscript. Are you with me? I will start my balancing with this one. This is where I'm going to start. This is where I'm going to start. I will try to balance this one first. So coming here now, I have what here? What number do I have here? 1, right? Since that one could not balance it, I will add what? 2. I will add anything you're going to balance will start from here. Are you with me? So I will add 2 here now. I will add. The volume is too much. Okay. Now, you add 2 here. By adding 2 here now, sulfur is now how many? Is it 2? I will now come here and add 2 to balance what? Thank you. Now, having balanced sulfur now, ask yourself, lead is now how many by adding 2 here? I will also add 2 here to do what? Balance lead, isn't it? Do you see the way we're going now? So add 2 to balance lead. Can you hear me? Can you know we talk? Okay, I'll be a go. Okay, now let's go. Is lead balance? 2 sulfur, 2 sulfur. Now the next thing to balance is what? Now we come 2 times 2. 2 times 1. Look at it. 2 times 1 oxygen is what? 2 oxygen. 2 times 2 oxygen. 4. 2 plus 4. So total oxygen here is what? 6, right? This is what we call, who can tell me this phenomenon in physics? What do we call this? What is causing this thing you're observing now? Physicists are here. Pardon? Is it echo? It's not echo. What is causing this thing? Resonance. What kind of resonance? Acoustic, or electrical, or stereo, or mechanical, or nuclear magnetic? Which one? Cheje. That is an assignment. Go and find out. Okay. Now, look up. It's not Obraya Kaineme now. Is it right? Let's focus on what we're doing. right. Do you remember we found 6 oxygen? Now, how many oxygen am I having here? What number will I use to multiply? Hold on. What number will I place here so that if I use it to multiply 2, I will get 6? So are you sure I should put 3 here? So 3 times 2 now. The question is what? Balanced. Now, check this one now. Can you do this one? Or everybody do this one? Is it the same thing? Thank you. You are too much. So, if in exam, they happen to write this kind of equation like this and ask you, what metallurgical process is represented by this reaction? What will you say? Roasting. Which means you heated sulfide ore in presence of what? Oxygen, and converted it to what? Oxide. Are you there? At the same time, the sulfur is oxidized to sulfur 4 oxide. Right? Then, after roasting, the oxides, of course, these gases will go away. Have you seen a chemical equation where arrow is placed like this? Yes. The moment you see this, they are telling you that it's a gas that is escaping. That is what? Going out. So the gases will escape, leaving behind these solids. Are you there? So this thing is collected and now put inside blast furnace. Inside what? And then heated with coke. It's now collected and mixed with coke and placed inside furnace, blast furnace. When you mix an oxide with coke or with carbon dioxide and place it inside furnace and heat it, such that you convert it to the metal, what process is that called? Is it smelting? So that is, the next stage is smelting. Smelting. How do you know that a process is smelting? When the reducing agent is coke or what? Carbon dioxide, right? So smelting. So during smelting, the oxide, the lead 2 oxide is treated with coke, heated with coke. If that happens, coke is a powerful reducing agent. I hope you know. As a result, it will capture this oxygen, making lead 2 oxide to reduce to what? Lead. And then itself will be oxidized to what? CO, right? CO, not CO2. It will be CO2 assuming this what is here is CO. Is it right? If it's CO that is here, then here will be what? CO2. But if it's coke here, then what you get here is what? Under that condition. The same thing will also happen to this one too. Is it my fault? Yes. How? I should off it. Yes. Then how will you hear me? I don't think that is the problem. The problem is the media should come and do something. Okay. Let's see if we can get better now. It's from here, not from me. Okay, so that is it. Please, no time. Yeah, you can write this. So after smelting, the next stage is what? Purification, right? Purification. Okay. Let's go now. Purification, right? So in purification, we want to remove other. Remember, zinc is here, right? Zinc is going to be produced with lead. So you need to find a way of removing lead from the impurities. So there are possible impurities that you need to remove from lead. Impurities like zinc. Okay. So you have to remove impurities. All right. Now let's proceed. Please, can you stop? The next thing we go into now is properties of lead. That's physical properties of lead. Now, is lead a metal? Is lead a metal? Begin to think of properties of metals. Can you think of any property of metal? Good conductors, malleability, ductility, sonorous. What again? Lustrous. Gini bu lustrous. I shine up here. Luster. Onwazo. Less dense. Are metals less dense or dense? Metals are generally of high density. Though metals are lower density than water. I hope you know that. Yes, the alkali metals have low density. Now, listen again. What about high boiling and melting point? Do metals have high boiling and melting point? They do, but not all metals. Not what? Some metals. What about hardness? What about what? Hardness. Some metals, most metals are hard, but few are what? Soft. There are some metals you can use knife to cut. Are you aware? Can you use knife to cut iron? If you cannot use knife to cut iron, it means that iron is harder than knife. Are you with me? Can you use knife to cut wood? Then if you can use knife to cut wood, it means that knife is harder than what? Wood. Are you with me? For you to use something to cut another thing, that thing you want to cut, the material you want to use to cut the other one should be harder than the one you want to cut. Is that right? So metals are generally hard, but some are soft. True or false? Can you think of any metal that is soft you can cut with a knife? Yes, the alkali metals. Lithium, sodium, potassium, rubidium, and what? Cesium. Cesium. They are soft. Cesium. What is the chemical symbol? CS. CS. Cesium. Okay? Now, apart from that, some other metals are also soft too. If you go to group 14 element, they're also soft. Group 14. Some of them are soft too. If you talk about group 14, tin is group 14. What are the members of group 14? Group 14 or IVA. What are the members of group 14 elements? Group 14 is same thing as what? This is the modern system of naming. This is the old one. IV is what in Roman system? 4, thank you. So element. What are the members of the group 14 element? Carbon, right? Carbon, silicon, germanium, what again? tin and what? Lead. Tin and what? Lead. Tin and lead. These are group 14 or what? IV. IV is 4. But look at it. If I'm using this numbering system, alphabet A must go with it. A or B. A or what? You use B if it is a D block element. If it is what? But you use A if it is a S block or P block. In the periodic table, you have representative elements and D block element. The whole element in the middle are called what? Transition. Transition, what does transition mean? In between. Okay? In between. Then we have group, you have a S block and P block, which are called representative what? Elements. And they constitute the main groups. The main what? In the periodic table. That is group 1 and 2, group 13, 14, 15, 16, 17, and what? 18. If you count what I've said now, you see that there are what? 8. 1, 2, 13, 14, 15, 16, 17, and what? 18. That is it. Now, group 14, look at the members here. Look at the members here. Now, look at these members. Of this one, these two, are they metals? This one is a non-metal, right? These are what? Metalloids. Metalloids. They're also semiconductors. They are elements that can be purified, that can be obtained pure. That can be obtained what? Up to 99.9% pure. By zone refining. By what? So, and as a result, these two elements, when they are in pure form, they are called intrinsic semiconductor. They are called what? They are called what? So, silicon and germanium are what? Intrinsic semiconductors. You can jot that. Silicon and germanium are intrinsic. Intrinsic semiconductor. Intrinsic or pure. Pure semiconductors. Silicon and germanium are intrinsic semiconductors. Tin and lead, are they metals? You know, metallic character normally increase down the group, right? Though it's not always true. Metallic character normally do what? Increase down the group. So this is a non-metal. These are what? Semi-metals, right? Or metalloids. Why these two are what? Metals. And they are soft. They are what? Because of their softness, when you mix them together, when you alloy them together, you use them to soda. To do what? Have you heard of soft soda before? Soft soda. Where have you seen soft soda before? Soft soda. Where have you seen it? In the market. Only in past question. Oh, sorry. How many of you have seen soft soda before? If you have gone to repair your phone or any of your electronic appliances, like your television or whatever, you have seen soft soda. The media man is not here. I would have asked him to show you. If you go to market to repair your phone, that is, if they want to solder something, if they want to add wire to your phone or anything, there is a tiny wire they normally bring out that is rolled on something. That wire looks whitish or grayish in color. Have you seen it? Have you seen it before? Now, when they bring something that looks like what? Pen, but it's hot, right? They'll be using it to melt it. True or false? That thing that melting is soft word, soda. Are you with me? But if you notice something, before they start melting that soft soda, there is something that looks like Vaseline, but yellowish in color. They normally collect and rub that place. Have you seen it? That one is called soldering flax. Soldering what? Soldering what? Jam can ask you that in exam. Soldering what? Flax. What is sodium flux? It is zinc chloride. Zinc what? What is the role of that sodium flux? To ensure that during that soldering, the oxygen does not do what? React with the lead or with the what? Tin. Are you with me? So, the flux, in fact, the function of flux in reaction is to eliminate impurity. To eliminate what? To eliminate what? So, the presence of oxygen in soldering will make the soldering joint to be weak. To be what? Weak. Abadocha the tin no koberege. Phone get down and eba I so that I'm making eba I so that I'm not down and I'm making a backup, right? It will pull off. So if it pulls off, it means that name again oxygen attack during the what? Soldering. That's why they normally use that thing to rub that place. Assuming he's around, I will ask him to be showing you the pictures so that you'll be seeing it. Okay? So now, soft soda is an alloy of what and what? What and what make up soft soda? Alloy of what? 50% 50% lead and 50% what? Tin. Alloy of 50% what? Yes, that's normal distance, and 50% tin. That is normal soft soda. Though there are various types of sodas anyway. So this is called soft soda for soldering electrical components. Who can tell me why soft soda is used? Why lead is used? Lead and tin are used in soldering. Give me one reason why they are used in soldering. I want you to be thinking. Remember we said for you to pass jam, you need to do what? Think and understand. Why do we use soft soda in soldering? Now, will you go and use a metal that is of high melting point that will take a large amount of energy, electrical energy to melt? Or do you need a metal that can easily melt with small electricity? Which one? Are you sure? The one that the current supplied by generator can melt, or do you need NEPA? Which one do you prefer? The one that every electricity can supply current to melt it, isn't it? So why do you think that lead and tin are used to make what? Soft soda. Why do you think? Give me one property you think that is possible. They have low melting point. Low melting what? That is the reason why lead and tin are used to do what? Make soft soda. They have low melting point. Is it right? So that small application of heat can melt it. When it is melted, then it cannot join the two components together, right? When it solidifies. Now, another thing is, I want you to listen. Another thing is on physical properties of lead. Lead, we have said that it has low melting point. Three of us. Do you know why lead has low melting point? Remember, most metals have low melting point or high boiling point. Which one? Sorry. Low melting point or high melting point. Which one do they have? High melting point, right? But you can see that lead and tin have what? Low melting point. Why? Why is the melting point of lead low? The question is, before you can know why melting point of lead is low, you need to understand what makes metals have high melting and boiling points. Are you there? What is melting, by the way? When something is melting, what is happening? Is our forces breaking? When something is melting, it means forces holding the particles are what? Breaking. So they are shifting apart, isn't it? What if that force, the force holding the particles are too strong? Okay? It means you are going to need what? Much heat. That is thermal energy, right? To break them apart. But if the forces binding the particles are weak, do you need a lot of energy to break them or small energy to break them? Small energy, right? So you can now see that, you can now think of why lead has low melting what? Point, right? It shows that the forces binding the crystals, is it weak or strong? Weak, right? So the forces are not that too strong. And what is that force? Is it metallic bond or covalent bond or ionic bond? Which one? Is it metallic bond or covalent bond or ionic bond? Which one? Metallic bond. You know, metallic bond exists in what? Metals. It binds what? Metal atoms in metal crystal. In what? To form a crystal. You know what is a crystal? Okay. So that is it. Now, why is lead? I want you to listen carefully. Why is lead having low melting point? I want all of us to write electronic configuration of lead so they can understand what we're saying. Because if you don't know how to write electron configuration of lead, you cannot understand this. Now, let us write atomic number of lead is what? Okay, let me help you with this. This is not a topic we're teaching, but let me help you with this. You know this, right? You know this? I don't want to tell you, I will not tell you how I got it because that's not what we're doing now. Huh? This one? No, I don't want it. I need to form a triangle. Okay, thank you. Now listen carefully now. Everybody should listen. Everyone should listen. Now, everyone listen now. You may learn what you may get something from there. Of course, I know you must get something from there. Now, look at this. You know, all these things here are called subshells. Say subshells. Subshells. In the periodic table, we have 4 subshells. 4 what? And 7 shells. 7 shells, K, L, M, N, O, P, and what? Q only. In the same periodic table, we have 4 subshells, S, P, D, and what? F. Okay? Now, when you are filling subshells, listen carefully. I've already arranged the subshell the way they should be filled. Who can tell me the maximum number of electrons S subshell can accommodate? 2, right? It cannot take more than 2, but can it take less than 2? That is S. So if I'm filling electron into S now, I can fill 2, I can fill 1, but I cannot have this. Can I have this? Because the highest number of electrons S subshell can have is what? 2, right? Now, what about P? What's the highest number of electrons it can take? 6. Right? P is not equal to 6. I'm going to show you something. Now, what about D? What is the highest number it can take? 10. F? Thank you. So let's now move. Let us write electron configuration of lead. I want you to listen. Do you want to try it? Yes. If I ask you to write it, you will fail it. You think you will write it? Yes. You think you know it? Yes. Or you write it? Just write it now. Let me see you. Now listen now so that you learn the writing. Now, lead, the atomic number of lead is 80. Now listen. Listen carefully. In a neutral atom, mercury is, oh Jesus, is it lead I'm talking about? Oh my God. Lead is what? Who can tell me? 82. I thought it's mercury I'm talking about. Now, let's go. Lead is 82, right? Now, let's write it. Lead being 82, I want you to listen carefully. Being 82, listen and see how we're going to write it now. How many electrons will I fill here? First of all, consider how many electrons that are here. Does this thing carry any charge? It means number of electrons is equal to what? 82, right? So I will come. How many electrons will I fill into S? 2, because the highest S can take is what? 2. How many? So after this one, not that in here to fill. I'll come to this one, right? How many will I fill here? 2, right? Not that in to fill. I will come here. How many to fill here? 6. How many to fill here? Tell me, how many electrons have I distributed now? 2, 2, 6, 2. How many now? After distributing this one, I will come here. Nothing else here, right? I will come here again. How many will I distribute here? 6. Now, how many will I distribute here? Total, how many have I distributed? 20. Now, has it ended here? Now, I will come here. I will start again here. How many will I fill here? Are you sure? So 10 plus the 20 I've added, and then here what? 30. Plus 6 here. 36. Plus 2 here. 30 what? 38. Plus 10 here. Plus 6 here. 54 is correct. Plus 2 here. 56 plus 14 here. 70, right? Plus 10 here. 80, right? Now, 80 now. But what I'm writing is what? What number will I add here to make it 80? So to make that 80, 82. 2. So 2 will be here. Right? Now listen now. I know you can do this one I did now. But see where the problem lies in writing. That's where people make mistakes. If I'm writing now, I'm not going to write the same way I have filled. I will write horizontally. All the things I have filled, I'll pick them horizontally. I'll pick this. Did I fill this one? I'll write it. How many did I fill into it? I'll write it. Did I fill this one? How many? I'll write this. Did I fill this one? How many? 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 10. Four. I did not omit it. When you are writing what you have filled, you write what horizontally. This is what they will not tell you. Sorry, it's not your fault. Is it your fault that you are not taught the writing? No. Maybe in your schools. Now look up. Listen carefully. So after this, if you like, you listen. After this, did I fill this one? Make sure when you are writing, write all the things you have filled. I filled this 10, so that is it. After this, I will come here. 4S. How many did I fill into it? That one I will clear your doubt now. It's not your fault. Did I fill this? How many did I fill into it? 4p6. Did I fill this one? How many? 4d10. Did I fill this one? How many? 14. Did I fill this one? How many? 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 Did I fill it? Are you sure? Check it now. Did I fill this? I filled it. Okay, let's check again. Are you sure we didn't fill it? We filled it. Can you remember now? We filled it before coming here. So how many electrons there? 2. So have 6s2. What else did we fill? 6p what? 2. That is the most acceptable electron configuration. Now listen, let me show you what will let you know that you are correct. After writing your electronic configuration, the last number here is the period. The last number must be the word period. It's a must. The last number must be period. And listen now, if I want to know the group where this element belongs, there are rules to know. See how to know. Check this and this. Number here and number here, are they the same? First of all, check what ended this periodic, ended this configuration. Is it P or S or D or F? P ended it, right? Now, because P ended it, this element is a P block. Is what? P block.
Please, who is Wa for Oyedika?
Thank you. Now, let's go to the periodic table. If you go to the periodic table, this is S block, D block, and what? P block. How many groups are here? 1 and 2, right? How many groups are here? No. 10 groups are here, total of 10. Now, how many groups do we have here? 6. Starting from 13, 14 toward 18. Okay? Now you have 10 groups here. 10. That which ended with 12, right? Now let's see. If you end the electronic configuration with P, where is it found? Is it found here or here or here? Here, right? It shows that before you get to it, after this one, you must pass how many groups? 10 groups, right? Thank you. Now watch it. Look at that 10 groups here. Do you see that? Look at that 10 here. Can you see that 10 now? Look at the 10 here. It is it. Now, if I want to know the real group of this element in the modern system, as long as number here and here are the same, I will add this to this and this. If P ends it, look at it. 2 plus 2 is what? 4 plus 10. So, lead is in group what? 14. Period what? Period 6 group what? 14. Check your periodic table. Do you have it? Where is the medium man, please? You need to show us periodic table. I want somebody to write electron configuration of copper. No, not copper, zinc. Okay, let me not make it zinc. Write this one. Okay, write this one. Titanium, write titanium. Atomic number is 20. Medium man, please, show a periodic table. Periodic table. Can you project periodic table for us so that they will see? Periodic table. Modern periodic table. Project it for us. Everybody write titanium using what we did now. Write titanium. Atomic number 22. Sorry. periodic table. And see another thing, look up. When you are arranging this thing, make sure that the numbers are arranged in correct order, increasing what? Order. Do you see that? That's when you are writing. But when you are filling, which direction do you follow to fill? Like this to fill. When you are writing, when you are filling, you follow this. But when you are writing, you do what? Follow horizontal. Okay? The problem is that many people use both horizontal and filling to write. That's not the writing. You use this one, the diagonal, to fill, and then use horizontal to write what you have filled. I want you to write titanium 22. May I not see so? Pardon? You are finished? Let me see what you wrote. F9. Please, do not put comma. Do not do what? And do not put equal sign. Did you see what I did? Do not put equal sign, because this cannot be equal to this. Take note. Let me see what he did. F9 there. You must understand this in today. F9 there. Sorry. F9 there. F9 there. F9. 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 Smash A1. Smash A1. A1. F9. Smash A1. F9. Nine and 9. 9. Arrangement against the Baba. Not properly arranged. Another person? 9. Smash A1. Let's go. Thank you. That's nice. He did not teach you the right thing. I'm sorry. It's not my fault. Okay. You heard what I said? When you are arranging, when you are filling, you follow like this. But when you are writing, if you go to your periodic table, this is what your periodic table was used to arrange. After writing, this number is the period. Do you get me? If you follow that thing that you have been taught, you see, you will not get the periodic table. You cannot. Do you get me? The people that arrange the periodic table is not the fault of our teachers. Not everybody. I was taught by the same people. But I decided to think on my own. All right. Thank you. Now, look at what we have written now. Now, I want you to look up here properly. This is the electronic configuration anywhere in the world, as long as this earth is concerned. If you know any other thing, kindly put it aside. Listen carefully now. After writing this, they can ask you in exam, what is the valence shell electronic configuration? Valence what? Valence shell means the outer what? Yes. Then the answer is this one and this one. The last two. Are you with me? The last two. If the numbers here are the same, is it right? Are you with me? But if the numbers here are not the same, the answer is just what? Only the last one. Are you with me? Why did I say the valence is just this and this? Because the numbers here are what? The same. And that is which shell? KLMNOPQ. 1, 2, 3, 4, 5, 6, 7. This is which shell? Which shell? P shell. Remember we have how many shells in the periodic table? 7. So that is it. Now, look at the mistakes some of you made. Titanium, how many electrons are in it? 22. I will come now. Everybody look up. How many will I fill in S? After this one, I will come to this one. How many will I fill here? Every S must take 2, right? Now, how many here? I will fill 6 here. Now, I'm making a total of what now? Then I'll add 2 here again. 12. Then I will add what here again? 6. Making it what? I will now fill this one, which is what now? 20, right? So I fill total of 20 now. How many remaining now? 2 is remaining. I will fill it here now, right? So I will fill this one too. Are you with me? Oh, ya be ya na-ekwu mmụta. Ihe a na-ekwu bụ gịnị? Mmụta. Gee ntị ka ịmụta akwụkwọ. Listen, gee mụta ya, gee mụ ntị. Ọkwa ifu ka nsi wee file ya now. Ọkwa ifu ka nsi wee file ya. Ngwa neze nne edezi ede, nezie ngede. Did I fill this one? I'll write it 1s2. Did I fill this one? Okay, can say idea now. I will write it 2s2. Did I fill this one? 2 pieces. Did I fill this one? How many did I fill in it? I'll write 3s2. Did I fill this one? How many did I fill there? Did I fill this one? How many did I fill here? I'll write 3d2. Did I fill this one? How many did I fill here? Listen. I am not here to convince you. I'm here to teach you. You want me to convince you? Convincing you will only take our time. It will only take our time. Now, what is the confusion now? What is the confusion? I want to know. Again, every confusion. Okay, nka kwesi bia before nka. Okay, ngwa negodi ya. Onka ka mma. Achọ nke ijiri aka gị wee judge ya now. Three D gini. Okay, nka okuya. Okay, nka. Now, ke period element anọ now? Period gini. If you go to violate, go to the periodic table. You have violated the periodic table. The periodic table, listen carefully now. Learn the writing. Because exam, what you are preparing for is objective questions. People can give you answers. Now, you see, sometimes in JAMB exams, even in WAEC, the answers will be wrong. But you have to choose the nearest word. You have to choose the nearest word. Don't worry, we're proceeding now. You will see many of them. So, this is not correct. This is not correct. Now, I will give you one jam question, which is also why question, and you see something now. Look up. I will show you. Look up. You know one thing. I told you that when you are feeling, you follow this way, right? Eh? Now, do you know why you will follow this way? Do you know the reason? Do you know the reason? You don't know, right? Do you know what is called phenomenal penetration of orbital? Do you know that? You don't know. Now, see why you have to feel using this form, this direction. Listen. Filling of electron into subshell must be according to increasing order. Increasing what? Listen. Filling of electron into what? Subshell must be in what? Must be in increasing order of Guinea. Increasing order of what? N plus L energy value. Say energy value. N plus L energy value of the subshell. Please note down this. Note it down. Note it down. Filling of electrons into subshells. Filling of electrons into subshells must be according to increasing order. Filling of electrons into subshells must be according to filling of electrons into subshells must be what? According to increasing what? Order. Increasing order of N plus L energy value. Look at it on the board. Look at it. N plus L. Small letter L, please. Must be according to what? N plus what? L energy value of the subshell. Of the subshells. Are you there? Full stop. This is called Afba principle. This is called what? Abba principle. Here, German word. Okay, German word. Yeah, do you know the meaning of this? Abba German. It is a German word meaning building, construction, arrangement. Ngwanaya. Okay, what you and because oh yeah, nag that cowards. You see, some of you are what I you will test with a cram. You don't want to understand. The moment you understand, you begin to ask what? Questions. You begin to challenge some things. Periodic table in a use. This electronic configuration accuracy does not work there. It doesn't work. Now, look at this. I want you to look up. How many of you have seen this symbol before? Have you seen this symbol? What is this? Notation of electronic configuration. General notation for what? That is this NL power X. General notation for electronic configuration. Look at it. General notation for electronic configuration. What does this N here mean? Principal quantum number. What does this L here mean? Azimuthal quantum number. What does this X mean? Number of electrons occupying the what? Subshell. Let me help you with that. Now, in a time I would have led into the real history of how these things came about, how Nelbo introduced the concept of principal quantum number, which was later rejected because it failed to satisfy some conditions. It failed to explain some certain natural phenomenon. Uncle, what about 5F14 and what? You can add it now, here. You can. I decided to form a triangle. Are you with me? I just decided to form triangle, that's all. Sir, Uncle, lead is under period 6. Class is lead, not period 6 here. Please, sir, please, can you project that period table again? Look at lead here. Can you see where lead is? Look at lead here. Let's see lead. From the electronic configuration here, lead is in period what? Period 6, group what? Group what? Group beginning? 14. 2 plus 2 plus what? Who can tell me why I added these two together? This number and this number are the same. Okay? So, that is it. Now, let's see now. Can you see where lead is here? Period. Look at it. Look at it. You have group 1. Group 1, group what? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Do you see that? Group what? 14. Period what? Let's go to period. Period 1, 2, 3, 4, 5, 6. Do you see that? I will follow it. I meet lead. Do you see that? This is where lead is. So the electronic configuration I'm teaching you is what you use to arrange the periodic table. Nothing more, nothing less. Now, please, still leave it. Okay, you can turn to the other one I'm doing now. Now, I want you to look up, everybody. Look up, everybody. Look up. Look up, everybody. Everybody, look up now. Look up now. If I have this, who can tell me we have this S, P. Okay, let me go like this. These are called shells. Say shells. What are the shells? K, capital letters, L, M, N, O, P, and what? Q. What are the any values? Say any values. What is, do you know the meaning of N? What is N? Principal quantum number. So this is the first shell. So therefore the any value is what? This is the second shell. The any value is what? This one is a. This one is a. So how many shells do you have in the periodic table? 7 shells from K to Q. Now we have subshells now. What are the subshells? S, P, D, and F. It must be small letters. It must be what? These ones must be capital. Shells are capital letter because they are like a house. That's what I will tell you about them. Then what are their LU values? The LU value for this one is 0. This one is 1. This one is 2. This one is what? Now listen now. I want you to pay attention. When we have, what do we say that this in is, class? What do we say that this in is? General notation for electronic configuration, right? Oh, there's no time I would have, yes, broke it down very, very well. Now look at this. N is what? Principal quantum number. L is what? X is what? Occupying subshell, N, right? Now, you see, if I write this, look up everybody. If I write this 2, 1 raised power 6. If I write this, it will cause confusion. It will cause what? What does this 2 here represent? Tell me what it means. Do you see that? What does this one here represent? Azimuth, right? Now, listen. It is to avoid confusion that scientists said, okay, since all these things are numbers, this one is a number, this one is a number, this one is what? Let us use alphabet to represent this one. And leave this one with what? Numbers. So as to avoid what? That was when this alphabet came in. In an even neku. So we now introduce alphabet to replace these numbers now. In an even neku. So if I write something like this now, 2P5, the P here is representing number what? In an even neku. This P here is not P, it's a number. But we know that if you write 21 like this, you have confused somebody. The person will be solving mathematics, isn't it? That is why we have to introduce alphabet to replace the second numbers. So you need to understand how things came about for you to understand. The love letters are too much. I'm coming. After this, in your questions will just vanish. No, look one. Now, what is there? I told you, did I mention alphabet principle here? What do we say about alphabet principle? We say that what? Filling of electrons into what? Is it subshells or orbital that I said? No, I did not say orbital. Subshells must be in what? Must be in accordance with what? Or must be in increasing order of any plus what? Energy value of what? Of the subshell, right? Now I want you to look up now so that I will clear your questions, your doubts. Watch it. I have this man and this man. I want to know the one I should feel first. Listen now so they understand it. I will come here. N plus L. What is N here? 3, right? 3. What is D? Go back here. What does this D represent? So I add 2. Come here. What is N here? Remember, we are using this NL, right? So N is the first number, then L is the second one, which you represent with alphabet, right? Now, this is 4. What is S? S is 0. Now, find this. What is this? What is this? 4, right? Compare this and this. Which one is smaller? So the one that has smaller N plus L value should take electron first. Should be filled first in an equal filling only. That is why this. That is why when you are filling, you fill 4s before filling what? 3D. But when you are writing, you have to do what? Write 3D before 4s. Why? Look at it. Let's go. If you come to the atom, you have what? K shell. L shell, M shell, N shell. Well, let's go. What does this K shell mean? L shell, M shell, N shell. So you see, and when you are arranging an electron, do you arrange from inside or from outside? From inside outward, right? That is why when you are writing down, you make sure that you follow like this. After writing for the first share, you write for the what? Second, you write for the what? But you only write what you have filled in an different negu. That is very simple. Ngwa. Please, priority. Achonki derum this element. Derum electronic configuration here. One period and group. You also. Chota period and group. You supposed. There the electronic configuration immediately. Thank you so much. Thank you so much. Excellent smash A1. F9. Smash A1. Smash A1. I2. Smash A1, of course. Let me see. Smash A1. I'm forgetting as well. I hope you are cleared. Group period 3. That's correct. What did you write? This thing is wrong now. The configuration is wrong now. Supposed to be 3D54S2. What did you do? What did you do? Look up. 2 here. 2. You feed 2 here. Feed 2 here. Feed 2 here. Sorry. Feed 2 here. Feed 2 here. Feed 6 here. Feed 2 here. Okay. After filling this, then you feed 6 here, right? Feed 2 here. Before coming to fill anything here. And this from here to here now is 20. So what are you going to be with 5? Why writing? Why writing is when you follow, you'll be picking what you have filled like this. But when you are filling, fill everything in this order. Until you stop. Until you exhaust all the number of electrons you are given. First question is not like this. Hey, it's not their fault now. They are Nigerians who don't have brain. They don't take well. If you have learned this one, the same thing, somebody else can ask this one and it make you confused. That's why I'm teaching the right thing. He said, you are confused. Why should you be confused? No, this one's supposed to be after this one. Look at it. When you are now picking now, when you are picking, you pick this. When you are now writing, this. Do you see that you finish with this place before coming here? When you are writing, but first of all, finish filling. Yes. Say you made a mistake. Now, where is that in? Fill 2 here. You fill 2, 6, 2, 6, 2, which is 20 now, right? No, now you have to be finish filling. You did not see the arrow. Did you see? Filling. Hey, fill everything finished to exhaust the number of electrons. Okay? If you fill this 2, this one should be 5. Because here is 20, then here is 5, right? Now, when you are writing down, write this 1s2, 2s2, 2p6,
3s2, 3p6, 3d5, 4s2. Correct. Very correct. Very correct. Very correct. Very correct. Which one? Mistake. Are you sure you followed the order very well? I see that you need feel.
Another person? Smash A1. Smash A1. Period 4 is correct. Smash A1. If number none as well. Smash A1. Excellent. Smash.
Okay.
Correct. Seba mad. Smash A1. Mad none as well. Man none as well. Ne kwa nandi man none as well. Smash A1. Smash A1. Smash A1. Smash A1. Smash F9. Smash A1. F9. Smash A1. Smash A1. Smash A1. Smash A1. Smash A1. What is this? S? 4?
S. Okay.
Smash A1. A1. A1 smashed. A1 smashed. So, final. Few people made a mistake. I'm happy you people have learned it. Most of you have learned it. Listen. How many do you feel here? What do you feel again? Then how many will you feel? Listen. Is it 5? Now, when you are writing, you write what you have feed, right? Did I feed this one? How many did I feed there? I write 1s2. Did I feed this one? How many did I feed there? I'll write it down. Did I feed this one? How many? 2 pieces. Did I feed this one? How many did I feed there? 3s2. How many did I fill in this one? 3 pieces. How many did I fill here at that time? 3d5. How many did I fill here? I will now stop. So, what's the last number in the configuration? So the period is what? Period 4. Let's look at the group. See the group now. If you want to know the group, look up. What ended this in? Is it P that ended it or not? What ended it? S, right? Because, listen carefully so that you understand the grouping. If S ends it, if the configuration is ended with S, and what is following that S is D, in a different neku, if the configuration ends with S, and what is following that S is what? This is called penultimate. Say penultimate. Penultimate means second to the word last. If the second to the last is D, to know the group, add this number to this number. In a different neku now. Open ifo son kabudi, to know the group, add this to this. That's if D is following the S, then you want to know the group, it is this plus this. So what group now? Group 7. Oh yeah, please find periodic table for us. Periodic table. Oh yeah, let's find out. What is the period here? Period is what? Group is what? All right, let's go. Period 4. 1, 2, 3, 4. That is period 4, right? So I will start checking from here. Then look up. Group 1, group what? Group 3, group what? Group 5, group 6, group what? Do you see that? That is a periodic table. So anything you are doing, make sure it's in order. Before time, because please, just give me a minute. Oya ye munkani oya meba. If you want to write this kind of thing, now watch. When you see 2 plus like this, it means that the thing has lost 2 electrons. And if now, how many electrons for say no lose go to? 23 kgs were there. So when I cheat then kita man and kaya apokya 2 yap then ofu yap kweba. Are you with me? So ya abuzi. Okay, yes, so some kaya up, yes. Oh 2 okay. So this one will go, remain this one. You don't know the group with ion, you know the group with neutral atom. In an different neku. You say what? Because what if this is not following it? Oh, thank you. Somebody asked a question. What is this not following it? You know, I said if S ends it, and what is following the S is what? Are you there? If what is following the S is D, then the group is this plus this, right? Now, listen, if this is not following, the next thing that can follow is what? P. In a different neku, open P ne soya na azu. The group is only this number. And if you P so S now, the group is only the number here. Is that right? Like something like this now. What you got in car? Watch in car now. Ngwanenka kiene so nka now. Okay, can you make it? Kienesia na kienesia. Kieneso S or Pinesia. Can the group now? Only the 2. Only the 2 here with the group. What about the period? So this element now is in period what? Sorry. Okay, yeah. Check it. 2 plus 2 plus 6 is what? 12, 18, then what? 20. Okay, Nafia? 20. In so S buru P, then the group is only the number on S. Is that right? Please, periodic table again. So you're going to find this in what? You're going to find calcium in what? Period 4. Period 4 group what? Let's find out. Period 1, 2, 3, 4. Queen Afia. Group what? 1, 2. Okay, back on. Okay. Thank you. Listen, akukwemwero magic. Imutagia, ngwanaya. Somebody said, why did I skip D? Well, let us find out. How many electrons am I to distribute here? Let's go. How many will I feel here? How many have I feel now? Oh, Google, no one care for. Okay, what don't care for? I will not go to D because no one here for. Do you see that? I will not go to D. And when I'm writing, listen, when I'm writing, will I write 3D? Did I feel it? I cannot write what I did not feel. I've answered your question. Thank you. You have question? You have question? Sorry, please make sure you ask your question. I'm coming. Of iron. Just remove this number here from this one. Remove this from this. 25 minus 2 is what? 23. Only 23 is what you now write. The same thing, the same way you feel this, that's what you're going to feel. Pardon? Now, because it is this 2 electron that was lost. What? Well, let's go. Now, listen, before you write electronic configuration of ion, first of all, write the neutral atom. Because the ion came from the word neutral atom. After writing the neutral atom, you can now begin to do what? Remove. If it's positive ion, you remove. If it's negative, you add extra one. Everything has procedure. Before you write the electronic configuration of ion, you must first of all write the neutral atom. Is it right? You don't need to be confused. Write what? Which? Electronic configuration of manganese. We wrote it before now. See manganese here now. See manganese here. That's what I'm asking you. The thing is that you don't want to understand something. You want to write electronic configuration of this. Before, listen, please, everybody listen. Before you write electron configuration of ion, you must first of all write that of the neutral atom. In an even before writing electronic configuration of ion, you must first of all write that of the what? Now, after writing the neutral atom, you can now write the ion. Now, this is the neutral atom. If I want to write this now, how many electrons are here? It means this man lost what? He lost 2. Which electron did he lose? When atom want to lose the electron, is it valence one that he lost or the inner one? The inner one, right? See the 2 electrons lost here. Huh? The valence is 4 now. The valence is the last one now. That is what he has lost. So this is remaining thing now. So this is now, look at it here. Have I answered a question? Thank you. Now you also age confused again, then we call it a day. Imechi meto yin agwa kade. Get into 1 minute. Do you see what is on the board? This element on the board, the electronic configurations are what? Abnormal. They don't do like others. Their own are abnormal. They don't follow this thing we have taught now. Okay, I'm coming. Please, a minute, I want to leave now. Mechano. Nenke kase apụta na exam ebe chromium. When if about abnormal configuration, get kemutia ozugbo na very simple. Get kemutia chromium bone okwa 20 gini. 24 ngwanaya. I want to write 24. I will fill how many here? I will fill 2 here, fill 2 here, fill 6 here, Phi 2 here. Phi 6 here. 18. Phi 2 here. 20. Phi how many here? 4, right? I'm supposed to phi 4 here. That is if the electronic configuration is normal like others, right? But it's a what? Abnormal. Look at what makes it abnormal. Normal, what I'm supposed to write here is what? 4, right? Now, but then how many here? Is it 2? Oh yeah, no, I can about phenomenon of penetration of orbitals. Of what? Of forgetting? So instead of fiber, it was observed that in chromium atom, this electronic configuration does not exist. In this state, chromium is unstable. Chromium is what? It needs to be stable. And what do? Look at it. Remove 1 from here and put here. Remove 1 from the S and do what? Put here. How many now? How many will be left here? So let's write it now. 1s2, 2s2, 2p6. Am I in order? 3s what? 2. 3p what? 6. 3d what? 5. And again. So if I write in all these elements, make sure here we put 1 electron from their last s. Where are you again? That SIN did the thing, is right? We put electron eba where are making Tien cause irap 1 eba in an if neku. Ngosi so se de copper. Ide coppers benaba. De coppers bosbo. So I drag an exam. How many electrons does chromium have in the penultimate subshell? Is it 5? 5 is the correct answer. Penultimate, second to the last. The love letter is too much. Please, we're done. No? Write copper and go your way. Please, the electronic configuration of tin. You can write it now. Smash A1 on them. It is go. Ngagupta me feed there. Is it 3D10 and 4S1? You are very correct. When design element of the configuration, yeah, in an even neku. Gekwa monti. It is electronic configuration. Obuna SBA endria. D ne so yanazo. Imana that element on agini D block. On agini. Obuna that game with obuna 10 electron on that D. Ipoy again non-transitional. Say non-transitional. So from it, is copper transitional or non-transitional? Copper is non-transitional. Copper is non-transitional. By definition, it is. But when I go into the ion, you see that copper 2 ion is transitional. Is what? So at this junction, we'll call it a day. I wish you good luck.